Charlie is combining 2/3 cup of sugar, 1/2 cup egg substitute, 2 cups of heavy cream, 1 3/4 cups whole milk, and 1 tablespoon vanilla extract. After pouring the mixture into the machine, we let it churn for about 25 minutes or until thickened. For our chocolate sauce, we combined 1 can of sweetened condensed milk, 2 ounces of unsweetened chocolate, and 1/8 teaspoon of salt. And we will put that over boiling water on a double boiler. Removing the hot fudge from the heat, you add a 1/2 teaspoon of vanilla extract and stir that in, and then add water to reach desired consistency. In a medium saucepan, we combine 1 cup packed brown sugar, 1/2 cup half and half, 4 tablespoons of butter, and a pinch of salt to make the caramel sauce. We are going to whisk this over medium-low heat for about 5 to 7 minutes, and then remove from heat and add a tablespoon of vanilla.
Hi, I'm Charlie, and I will be presenting the phase change part of our cooking project. Phase change occurs when boiling the water to heat our chocolate sauce. The water molecules began as ice, their solid form. As the ice melted into water, the intermolecular attraction forces were not as strong, which resulted in the molecules spreading apart. As the liquid water began to boil, the hydrogen bonds that were present between the water molecules break and the molecules spread even further apart. In the ice cream, the process is the exact opposite. Molecules began slightly spread apart in their liquid state, but grew closer as they turned into ice cream.
Hi, my name is Charlotte, and I will be talking about the conduction and convection in our foods. To make our caramel, we use conduction, which is the heat transfer through direct contact. The fire from the stove produces heat that directly touches the bottom of the pan with sugar in it and melts the sugar into caramel. Although you could conceivably melt the chocolate in this way, it is very easy to ruin it because the cocoa particles will separate from cocoa butter and burn. To avoid this, we used a double boiler, which uses convection to heat the pan to provide a less harsh, even heating. The double boiler works by boiling water in a pot and placing a bowl of what needs to be heated on top of it so that it doesn't make contact with the water. Because convection is the heat transfer through the movement of water or gas, the steam produced by the boiling water heats the bowl, thus avoiding direct contact causing separating and instead melting the chocolate.
Hey, my name is Willie Cowperthwaite, and I will be explaining the process of endo and exothermic reactions in cooking our food. Ice cream is exothermic. This is because the heat energy is being transferred out of the system and into the surroundings. With the ingredients in the middle of the bowl, the outer layer is then frozen, which causes the heat energy to transfer from the ice cream to the cooling liquid inside of the bowl. This makes the ice cream able to freeze and the cooling liquid to thaw. The process of making hot fudge is endothermic. This is because heat energy is being transferred into the system from the surroundings. With the double boiler, heat is first transferred into water and then to the chocolate so that it does not burn. The heat energy causes the intermolecular forces to be not as strong, resulting in the substance to melt. The process of making caramel is endothermic, the same as hot fudge, except instead of the heat energy being transferred into water and then hot fudge, the heat energy is being transferred directly into the caramel.
Hi, my name is Grace Stromer, and I'm going to be talking about freezing point depression. Melting or freezing point of a substance is the temperature at which it changes between the solid and liquid states. When a solute such as salt is added to the solvent of pure water, the new solution has a different freezing point than the solvent originally had. This is called freezing point depression. We use this principle in making ice cream. When water freezes, the particles take on an orderly arrangement as a solid called a crystal lattice. When rock salt was added to the ice in the outer bowl of the machine, the salt particles disrupted the order of the crystal lattice. Instead of attracting with the other water molecules through hydrogen bonds, the water molecules attracted to the dissolved salt particles through dipole-dipole interactions, which are stronger attractions. It therefore takes more heat energy to separate these attractions. This allows the heat to be transferred out of the ice cream and into the salt solution at a faster rate in an attempt for the system and surroundings to reach equilibrium, causing the ice cream to freeze quicker.